Okay, so let's revise through this P191 quiz paper. And the first question, question one, part A is saying the mass of a solid cube is 856 grams. The mass of a solid cube is 856 grams, and each edge has a length of 5.35 centimeters. Determine the density, rho, and of the cube in its base SI unit. So I don't know how the question was supposed to continue, but for now, we're just going to consider it as determine the density of the cube in basic SI units. So this is a very simple question because we have already been given the mass. We've been given mass of 856 grams, and we've also been given the length of each side of our cube. So we know to say density, which is represented by rho, this is equal to mass over volume. So that means from the information that we've been given, we're supposed to calculate volume. But before we do that, we need to convert the units of measurements that we've been given in this question into their basic SI units. For example, 856 grams should be converted into kilograms. And now we're going to do that. We are going to divide this guy by 1,000. So say 856 divided by 1,000 for 1 kilogram. This will be equal to 0.856 kilograms. Like this. Whilst we have been given the length of each side, say it's 5.35 centimeters. But what are we supposed to do? We're supposed to convert this unit or this measurement that we've been given into meters, which is the SI unit for length. And when we convert that into meters, that's when we should be able to calculate our volume from there. So we're going to say 5.35 centimeters into meters. This will be divided by 100, and it will give us 0.0535 meters. Now, in order for us to calculate our volume of a cube, this is a cube that we've been given. So to calculate volume of a cube, we're going to say our V will be equal to what? Our V will be equal to L to the power 3, of which L is just the length of each side. So my volume of this cube will be equal to what? Will be equal to 0.0535 meters to the power 3. That means my actual value of the volume will be equal to, okay, it's a very small number. I'll say 0.00015 cubic meters. I can just leave it on here, but it continues to say 0.0013065,375 cubic meters. But we can just get this one. At least the proportion of us getting a different answer is very small. So let's use that one as our volume. So we're now going to introduce the formula for our density. Rho is equal to mass over volume. And we said our mass is 0.856 kilograms divided by 0.000153. Well, let me just write the whole of it. 0.65375 cubic meters. If I punch that into my calculator, I'm getting value of density as equal to 5592.2 kgs per cubic meter. Kgs per cubic meter. So that is how simple this question is. That's how we can calculate the density of this solid cube. Mass over volume, then you convert our units of measurement into the required basic SI units, then we are done. Let's go to question B. And question B is saying, show that the expression half mv squared is equal to half mv squared, or half mv final squared is equal to half mv initial squared plus the square root of mgh is dimensionally incorrect. So we want to prove to say this expression is dimensionally incorrect. And how do we do that? We use what we call the principle of homogeneity. This is actually dimensional analysis. And what we're going to do is we're going to check if what we have on the left-hand side is actually equal to the right-hand side. Or I can just simply say the dimensions on the left-hand side should be equal to the dimensions on the right-hand side in order for us to conclude to say the expression or a formula is dimensionally consistent or is dimensionally correct. So what are we going to do? Let's start by introducing the dimensions of each formula or each side of our equation. So we have half, but since this is dimension analysis, we are going to ignore all the constants that we have here, which means the actual formula that we want to deal with is mv squared being equal to mv squared plus the square root over mgh. This is the formula that we're looking for. So what are we going to do? We're going to introduce the dimensions of each. So m here is for mass, v is for velocity, then it's squared like that. So I'll say my mass with dimensions m multiplied by the dimension of velocity, which is Lt to the power minus 1, squared like that. This is equal to what? This will be equal to the dimensions of our mass multiplied by the dimensions of velocity, which is the same, Lt to the power minus 1, squared like that, plus the square root of the dimensions of mass, which is still m, multiplied by the dimensions of gravity. And gravity here is the force of acceleration. So we're going to say multiplied by Lt to the power minus 2, multiplied by h, of which h here is just simply representing height, and height is the same as length, ladies and gentlemen. So what are we going to do? We're just going to put L like that. So this is our simplified formula into its actual dimension. So I'm going to distribute the squares on both sides of our equation. I'm going to have mass multiplied by L squared t to the power minus 2 like that. This will be equal to m L squared t to the power minus 2 plus, if anything, or if any expression is under a square root, that means that whole expression is actually expressed to the power of half. So what am I going to do here? I'm going to say m, which is the dimension of mass, multiplied by Lt to the power minus 2, multiplied by L. This will be in brackets to the power half, like this. This is our simplified equation. Now, let's distribute the half in the brackets there. Okay, so this is the same as I'm having my m L squared t to the power minus 2. This will be equal to m L squared t to the power minus 2 plus, I'm going to have my m multiplied by half like this. Then this L multiplied that L is going to give us L squared, which means L to the power 2. And we're going to have L to the power 2 multiplied by half like that, which is going to basically give us 1. So it's the same as I just discard that and leave it like that. Then I have my t to the power minus 2. It is also the same as I'm having t to the power minus 2 multiplied by half like this, which is just going to give us a t to the power minus 1. So I can erase this and just say t to the power minus 1 like that. Ladies and gentlemen, that is our simplified version of this equation that we have. And if we check this equation, you can already tell that we can't simplify this equation any further. We can't add these different expressions that are on the right hand side. And since these guys can't be added, you can already conclude from here to say the left hand side is not equating. The left hand side is not equal to the right hand side. And if you ever lead into that or into this observation or this observation, yes, what are you supposed to conclude? Your conclusion is that the equation that you are having cannot dimensionally stand, is not dimensionally consistent, and hence is not dimensionally correct. So what is our conclusion here? We can just say equation is dimensionally incorrect because the dimensions of the left-hand side are not equal to the dimensions on the right-hand side. So from here, ladies and gentlemen, we've been able to prove that this expression is actually incorrect. And when we reach that point, that means we've been able to prove that this guy cannot stand. Okay, question 2. Question 2, part 1 is saying distinguish between scalar quantities and vector quantities. Distinguish between a scalar quantity and a vector quantity. So this is actually very simple. We discussed this in class already, and we explained to say when we are talking about scalar quantities, we say they only have magnitude. Only have magnitude, whilst if we are talking about vector quantities, these have both magnitude and the direction. So ladies and gentlemen, this is the major difference that you are always supposed to talk about when you are talking about the difference between a vector and a scalar quantity, because we explained in class to say Scalar quantities can be fully defined with only their magnitude. For example, you can talk about temperature. If you just say the temperature today is 15 degrees Celsius, you have fully described the temperature. But when you are talking about vector quantities, you have to describe them using both direction and the magnitude. For example, if you talk about acceleration or force, you are supposed to specify to say the force is 10 newtons west. The force is 10 newtons directed at 30 degrees from the positive x-axis. You are describing it using both magnitude and direction. And hence, you are given your difference between a scalar quantity and a vector quantity. Let's go to part 2. Part 2 is saying, four coplanar forces act on a body at point O, as shown in the figure. Find their resultant force. Find their resultant force. So this is a very simple question. And on the methods of vector manipulations that we talked about in class, you can use the one which involves resolving of your vectors into their respective x and the y components. Then at the end, we are going to apply the Pythagoras theorem, where our magnitude for r will be equal to x squared plus y squared, like that. So let's use this approach. Let's use the resolving of our vectors into their x and the y components. And I said when we are resolving vectors into their y components, one of the simple methods that you can actually use is following directions or following their directions with respect to the positive x axis, such that if I'm talking about this one, I'll say it's directed at 45 degrees from the positive x-axis. If I'm talking about this one, I'm going to say it's directed at this 30, or since I know to say this is a straight angle, which means it is out of 180 degrees, I'm going to draw my vector up to that point. Then my direction of the 110-degree Newton vector will be 180 minus 30 degrees. This is going to give us 150 degrees from the positive x-axis. The 160 Newton vector, we're going to do the same. We're going to get this direction from the positive x-axis. And I'm going to say 180 plus 20 degrees that we have here to get the final direction as 200 degrees from the positive x-axis. Then I have this other one, which is along the x-axis or the positive x-axis, of which you can just consider the direction of this as 0 degrees on the positive x-axis. So what are we going to do here? This method is the one which is very simple, because when you use this one, when you're trying to find the sum of your x and y components, you are not supposed to panic or supposed to start using the negatives and positives, because other than this one, first let me write them down, because we're going to use a table. If you're not sure, just use a table so that you keep your data clean and as simple to observe and actually manipulate. So I'm going to say I have a table here where I'm going to keep my x component in there and my y components here and the actual vector there. So what am I going to do? I'm going to say the 80 Newton vector here, which is directed at 0 degrees, is going to have an x component. And since we are following the directions from the positive x-axis, the x component is automatically going to carry the cosine, whilst the y component is going to automatically carry a sine. So I'm going to say my x component will be 80 cos 0, whilst my y component will be 80 sine 0. What other vector do I have? I have a 100 Newton vector directed at 45 degrees from the positive x-axis. The x component will be 100 Newton cos 45, whilst the y component will be 100 Newton sine 45, like that. We have 110 Newton vector, which is directed at the calculated 150 degrees. The x component will be 110 cos 150 degrees, whilst the y component will be 110 sine 150 degrees, like this. The other one is the 160 Newton vector, which is directed at the calculated 200 degrees from the positive x-axis. We are going to say the x component will be 160 cos 200, whilst the y component will be 160 sine 200 degrees. That, ladies and gentlemen, is how we're going to handle this one. But if you don't want to follow the method for calculating your vectors from the positive x-axis, you can calculate them individually. And remember, I said, if you're looking at them individually, what are you supposed to follow? You're supposed to follow each vector with respect to where the theta that you are using has been given. And the component which is adjacent to the theta that you've been provided with is the component which is always going to carry a cosine. I explained this in class. So which means for the 100 Newton vector here, since the 80 Newton vector is already along the x or the positive x-axis, that means this guy is only containing the x component. What about the 100 Newton vector? We're going to have two components. We're going to have an x component there and a y component there. What about the 110 Newton vector? It is also going to have its x component pointing in that direction, whilst its y component will be pointing in that direction. What about the 160 Newton vector? It is also going to have its x component pointing in that direction, whilst its y component it's pointing in that direction. So which means this guy here is the y. It's away from the theta, so that means it's going to carry a sign. This guy is away from the theta, it is also going to carry a sign. This guy is adjacent to the theta, which is the 30, so it is going to carry a cos 30. This guy also is adjacent to the 20 here, so it is going to carry a cos 20. This guy so this guy, the x here, is adjacent to the 45 degrees, so it is going to carry a cos, whilst this guy, the y, is away from the 45 degrees, so it is going to carry a sine. And when you are finding the summation of the x and the y components, what are we going to do? We are going to notice the direction of this guy. This direction is the negative x direction. This one is the positive x direction. Even here, we have the negative y direction and the positive y direction. So the components that are pointing in the positive x direction, add them. Whilst the components that are pointing in the negative yx direction, subtract them. The same applies in the y-axis. The components that are pointing in the positive y direction, add them. Whilst the components that are pointing in the negative x direction, what are supposed to do? Subtract them from your summation of x components and the y components respective. Now that we followed the one which is the simpler one, which we're just following the direction with respect to the positive x-axis, what are we going to do? We're now going to start tabulating the actual values of the x and the y components. So what am I going to do? I'm going to say my Rx, which is the resultant in the x, will be equal to what? Will be equal to the following. I'm going to say 80 cos 0, 80 cos 0, of which cos 0 is basically 1. So this is just going to give us 80 plus 110 cos 40, or 100 cos 45, cos 45. This is giving me 70.71 plus 110 cos 150, cos 150. This is giving me negative 95. So you've seen to say, even if we follow the one of using the direction with respect to the positive x-axis, the ones that are in the negative x-axis will still be given as negatives on your calculator. So say minus 95.26, then plus 160 cos 200, of which this should also give me a negative since it was pointing in the negative x direction. 160 cos 200. This is giving me negative 150.35. 0.35, sorry. And now we can find the sum of these. I'm going to say 80 plus 70.71 minus 95.26 minus 150.35. Okay, so I'm getting Rx. This is Rx. Why did I write Ry in the first place? This is Rx will be equal to negative 94.9. So that is the summation of our x components. Then let's go to our Ry. Our Ry will be equal to, we're going to use the same approach. We're going to use the same approach. So let's say 80 sine 0, which is basically going to give us a 0. 80 sine 0, which is giving us a 0, plus 100 sine 45. 100 sine 45 is giving me plus 70.71. Then we have 110 sine 150. This is giving me 55, so I'll say plus 55 and plus 160 sine 200. 160 sine 200, which is giving me negative 54. Negative 54.7. Okay, so this is what I have. Now let's find the summation of our y components. So our RY will be equal to 0, 0 plus 70.71 plus 55 minus 54.7. And this is giving me a total of 71.01. So ladies and gentlemen, if this is the summation, we've now found our Rx and our RY. What are we going to do? We're now going to introduce our formula. Instead, I'm out of space. Let me just go to my blackboard. So we're going to say our magnitude of R will be equal to Rx squared plus Ry squared. So this will be equal to, we found our Rx to be negative 94. Is it 94? Negative 94.9. 94.9. This will be squared plus 71.01. 71.01. This also squared like this. Okay, so this will be equal to negative 94.9 squared this is going to give me something like this. Let me say negative 94 94.9 squared. This is giving me 0.01 plus 71.01 squared. This is giving me 42.42 like this, and I'm going to add the two values. That means under my bracket or under my square root, having 14 or 48.4301. And if I square root that one, I'm going to get an answer which is equal to okay, so I'm getting an answer which is equal to 118.52 newtons. So this is our resultant. This is our resultant of the four coplanar vectors that we've been given. 118.52. Yes. So that is all. I don't think they asked us to find the direction. I don't think so. Find the result. Okay, yes, they only asked us to find the resultant. But if we want to find the direction in let's just do it real quick. So we're going to say tan theta is equal to Ry over Rx, of which theta will basically be equal to the tan inverse of Ry, which we found to be 71.01, the tan inverse of 71.01. Theta will be equal to the tan inverse of 71.01 divided by negative 94.9. Okay, so I'm going to say theta here will be equal to the tan inverse of 71.01 divided by 94.9. So this is actually giving us a negative 7.4 4826. So I can just say 48 with decimal places like that. So I'll plug this the way it is into my calculator. Say tan inverse over negative 7.48. The tan inverse of negative 7.48. This is giving us 82 degrees, 82.4 degrees. So this, ladies and gentlemen, is the direction of our resultant. But if you look at the two components that we found for the Rx and Ry, those guys do not show that our resultant is in the first quadrant, because that is going to be our direct theta if our resultant vector is in the first quadrant. If you can check here, the x component is negative and the y component is positive, which means this resultant vector is lying where? It is lying in this quadrant, which is the second quadrant. And how do we calculate theta in the second quadrant? I'm going to say in the second quadrant, second quad, theta is equal to what? Theta is equal to 180 minus alpha, and we're going to equate alpha to this guy that we found here. So that means our theta will be equal to 180 minus 82.4. That means our direction of the theta from the positive x-axis is equal to what? It is equal to 180 minus 82.4, and that is giving me 97.6 degrees from the positive x-axis. So that, ladies and gentlemen, is the direction of our resultant vector from the positive x-axis. And if we reach that point, that means we are done with question 2, part 2. Let's now go to the third question, which is question 3 is saying a girl stands at the top of a cliff and throws a ball vertically upwards with a speed of 12 meters per second as illustrated below. So we've been given this diagram, give us the whole path of the ball and the height of the hand from the ground. At the time the girl throws the ball, her hand is straight. Her hand is a height h above the horizontal ground at the base of the cliff. The variation with time t of the speed v of the ball is shown below. So they've given us a speed time graph. And they're saying speed in the upward direction are shown as positive, and speeds in the downward are shown as negative. Determine the time in which the ball, 1, reaches maximum height. So these questions, we are just going to get the answers from the actual diagram that we've been given here. There's no need for us to start calculating, because these diagrams that we've been given, like this one, it is already containing everything, the speed time graph. So what are we going to notice? We know to say when a ball reaches its maximum height, it is going to stop for an instant, which means velocity is going to become 0. And if I zoom into this diagram, there is at this point where the velocity becomes 0, all the way from 12 here up to this point when it is 0. And how much time had elapsed before it reached 0? Because the moment the velocity reaches 0, that means it has reached its maximum height. So that is it at 1.2 seconds. 1.2 seconds. Since this diagram is drawn to scale, we can tell to say each box there is representing 0.1. So I'm going to say my time, the time that it took this ball to reach its maximum height is actually 1.2 seconds. Like that. So the time where the ball hits the ground at the base of the cliff, from the time this ball is thrown, we're just going to notice where this graph is ending, because that is where the motion is ending. So here it is, you can tell if I zoom this diagram in again, you can tell to say, see, 4.1234 seconds. 4.4 seconds. From the time it's thrown to the time it hits the ground, it's 4.4 seconds. Then the last question, they're asking us to say, determine the maximum height above the base of the cliff to which the ball rises. So we're supposed to calculate the maximum height above the cliff. So what are we going to do first? So we're going to use the formula v squared is equal to u squared plus 2s, like this. So From this equation, we're looking for displacement. We have the acceleration because this is gravity, 9.81 meters per second squared. Then the initial velocity, we are calculating this height from the topmost point here. And we know to say at the highest point, the velocity for an instant will be what? Be 0 meters per second. So that means our initial velocity is 0. What about the final velocity? We're going to get the final velocity from the graph that we've been given. So if I zoom into this diagram, just like this, you can tell to say it's also drawn into onto scale in the y-axis, and each box here is representing 0.1. So at the point where this motion is ending, the final velocity of the boy is actually 30. Oh no, the scale in the y-axis is 1. Each box is representing 1. We're going to say the final velocity, if we're following this box or this scale which we have here, is actually 32 meters per second. We're not going to follow the negative and the positives that they're talking about here, because we know this is just to show that the velocity is actually now for the motion of the ball going down. So this is actually 32 meters per second. That's the final velocity. So this is what we are going to use into our formula here, and I'm going to plug it in the way it is. So I'm going to say 32 squared will be equal to 0 squared plus 2 multiplied by A, which is 9.81, multiplied by S. We're looking for S here. So 32 squared, this is equal to 1024, being equal to 2 multiplied by 9.81. This is 19.62S divided by 19.62, even this side divided by 19.62. And our displacement from the highest, from the maximum height will be equal to what? Will be equal to this guy, or let's say 1024 divided by 19.62. And this is just actually 52.19 meters. So that is the height, or the maximum height that the ball reaches from the bottom of the cliff, or from the level ground. And that, ladies and gentlemen, was the last question. And if we reach that point, that means we are done with this tutorial sheet. So I'm not tutorial sheet rather, but quiz paper. So we'll continue with our revisions before you write your quiz. Make sure you subscribe to my YouTube channel and also register for our tuitions. I've included the whole process for registration in my description of the YouTube channel. So all you can do is go there and actually click on the link, create your account, or download the app from Google Play Store, and log in, then register for your desired course. We have all other revision papers or quiz revision papers on our drive, and if you want to have access to them and different more materials, including our recorded classes, just register with us and excel in your academics. Thank you very much, and stay blessed.